All right, guys, today we're going to talk about graphing square root and cube root functions. We're going to start by looking at the parent function of square roots. Then we're going to look at the parent function of cube roots. All right. Now, the parent function for square root is f of x equals the square root of x. And the parent function for cube root is f of x equals the cube root of x. Now, just as a rule of thumb, I think we've looked at this before, but when you look at the square root of x, we're looking at, for instance, -2, -1, 0, 1, 2. I'm even going to go to 4. All right. We know we can't take the square root of a negative number. It's imaginary, so we're just going to get an error message, or I'm just going to put a little dash. You feel free to do that too. Square root of -1, just put a dash. The square root of 0, we know is 0. Square root of 1 is 1. Square root of 2 gives us 1.4 approximately. And square root of 3 gives us 1.7 approximately. The square root of 4 is 2. All right, the square root of... give me 1 second here. Okay. All right. So... all right, now we can create our coordinate plane. We're just gonna do a little simple one. I'm gonna elongate the x-axis here a bit because we're gonna need 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And if you want, you can feel free to label if you need to or want to. Just for... okay. And we're just going to plot these points. So we have 0, 0 in the middle. We're going to put, we're going to graph 1, 1 or plot 1, 1. Plot 2 and 1/4, which is just over 1 a bit. 3 and 1.7, which is just above 1.4. And then 4 and 2, so we're going to go up a little bit more. All right, now we're going to just connect, and we can continue, so we're going to draw an arrow to represent the continuation. And this is the graph of the parent function for square roots. All right, and we're going to do something very similar for the cube root of x. When we start talking about cube roots, I am going to use a little bit of my knowledge to help us out here. Why? Because to save time. So let's say we have, I'm going to do a simple. -8, -1, 0, 1, and 8, okay? If in your calculator, and if you don't know how, we're asking ourselves, what times itself 3 times gives us -8? And if you can't answer that, you can always go in the graphing calculator, press math. Notice I have a TI-84 Plus. Okay. All right. So go to math, tap 4, because that represents the cube root. Type in -8. And it's going to let you know that answer is -2. If you do the same for -1, the answer is going to be -1. For cube root of 0, that's 0. Cube root of 1 is 1. Cube root of 8 is 2. All right, from here, to make our lives easier, because of limited space, we can count by 2. So this is 2, 4, 6, 8. 2, 4, 6, 8. And this is 1, 2, 3, 4. 1, 2, 3, 4. You may want to label this just so that it's clear. We're counting by 2s on the x-axis. 2, 4. And we're counting by 1s on the y-axis. Okay. Okay. So it's our x-axis and our y-axis. So from here we have -8, -2. -1, -1. 0, 0. All right, and I probably should use this color. That's what I want to use. Okay. Okay. And here's what the graph of the cube root of x, the parent function, is going to look like. Now, there is something that we kind of left out here, which was dealing with, I guess you could say, our key feature, or domain and range is the key features that we're particularly going to look at. So when we look here, notice because there are errors at -2 and -1, our domain starts at 0 and our range starts at 0. So we look at our domain, it starts at 0 and then it goes to the right or it increases. So our domain here is going to be x is greater than or equal to 0. Our range is going to be the same. Y is greater than or equal to 0. Now, when we look at the cube root of x, there are no limitations on our x and y. Nothing gives us errors. We have negative numbers. We have positive numbers. And if we wanted to look in between -8 and -1, we would find decimals here. Okay, so this would be all real numbers. So our domain is all real numbers. And our range is all real numbers, okay? Now let's say, for example, we want to graph y equals 1/4 x, and then, I'm sorry, the square root of, I just totally checked that up. Hold on, y'all. All right, let's come back. All right. Okay, y'all. Good enough, good enough. All right, so let's try this again. Y equals 1/2 square root x, okay? Let's say we want to graph that and we want to state the domain and range. We're asked after doing this to compare the graph with the graph of square root of x. And notice y equals square root of x is its parent function. So that's what we're comparing it to. Now, when we look at this, x, y, we're going to look at, instead of us going in between, we're just going to go to the ones we know work. We're not going to go to negatives because we know that gives us errors. So let's start at 0, 1. We know 4 will give us a whole number. And let's go all the way to 9 because the square root of 9 is a whole number as well. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3, right? This is representing the square root of x. Now, if we take a half of that, which is what the function that we're given, then 0 is still 0, but a half of 1 is just a half. A half of 2 is 1. A half of 3 is 1.5. Okay? So when we look at this, then what we have is, I'm gonna just do a little something here. I'm probably gonna make this a little bit longer. So this is gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? And this will be our regular 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. It doesn't matter that part. All right, the part we're paying attention to is the first quadrant. So let's make sure we have this right, have this right. And from here, what we're gonna do is we're gonna go ahead and do our parent function. We had that in blue up here, so let's do that in blue here. So it'll be 0, 0, 1, 1, 4, 2, and then 9, 3. Right? That's what the parent function looks like. And then we're gonna do y equals 1/2 square root of x. Let's do that in yellow. So start at 0, 0. But now for 1, it's gonna be 0.5. For 4, it's gonna be 1. For 9, it's gonna be 1.5. So we have something that's kind of like here. All right, so this is our y equals 1/2 square root x, while this one is y equals the square root of x. And so if you know anything about transformations, the y equals 1/2 square root of x is vertically compressed in comparison to its parent function, the square root of x. So what we're gonna write here as part of our description and comparison is that y equals 1/2 square root of x is a vertical compression. Why is it vertically compressed? Compression means like compressing towards the x-axis, compression. So this is vertical because vertically is like shrinking. So vertical compression is a vertical compression of its parent. And when we talk about domain and range, it still has the same domain and range, even though it's going to be a little bit slower reaching the numbers of its parent. So domain is still domain. X is greater than or equal to 0, and the range is y is greater than or equal to 0. All right. Let's look at another example. Let's look at graphing y equals -3 cube root of x, and determine its domain and range. Compare the graph with y equals the cube root of x. So this is y equals -3 times the cube root of x. All right, so I'm gonna have you guys do this and we'll review it in class.